Gestation length, so human pregnancy. Now this is a little bit up for grabs as far as these figures. So what I've done over time is I've collected data that I get from medical journals and I average it. And what I've come up with is a pretty good average. I gotta look it up here real quick. On average, a pregnancy lasts 266 days. Which is roughly your 9 months that we always use as a reference point. But if you go down by days, you actually have a little more precision. With a standard deviation of 16 days. Days. Okay, so there's our two pieces of information that we have to start off. We've got to know that the average length is 266. I'm going to redraw this curve because I kind of destroyed it now. And Tiffany, like you said earlier, I mean, everything comes back to this normal curve. It all centers on this curve. So it all centers on 0, and then it pops up by 1s, and then down by 1s as well. So now there's the standard normal. Let's put pregnancy, human pregnancy, down on that curve. What number's on the middle?
0.
Well, on the z-score, yes. But for human pregnancy, what's going to be in the middle? 266. And I'm going to put just once days in parentheses down here because there is a unit on this graph. The standard normal curve is the only bell curve without a unit. It just has 0s, 1s, and 2s, and 3s, and numbers. But any other general normal has to have a context, as Renee correctly said, data. It has to have data, and data is going to have some kind of a unit. When Max and I changed the brakes on my bike, I was tracking how many feet it took me to stop with 2 different kinds of brakes. I normalized that down to the 1s and 0s when I was done to analyze it, but at the time I collected the data, it was all feet and inches. So thank you. Okay, good. 16 days is the plus or minus, yes. So that means we go up to, check my math on this one, 282. And then 298. Keep checking me. And then 314. And then let's stop talking about it at that point because I don't think a pregnancy should last any longer than that. It could. Theoretically speaking, the human body could be programmed to have a pregnancy last 3 years.
No, but
there's a realistic limit on.
Yes. At 42 weeks.
Hold that thought.
Yeah.
We'll get into that too.
Okay.
Yes, good, because I'm going to look at the extremes today.
Yeah.
Thank you. It's exactly where I want to go with this and both of these come from questions that I've encountered in my life. Like, really? Then what about this? And that's what you're getting to next. But we'll save that one for a second, if you don't mind. Just because of this text I got yesterday morning and it's still fresh in my mind. Now let's go this way. Let's go for short pregnancies. Yes. So 16 down, 250, I think. And please check my math on this. Make sure I'm doing it right. 16 down, 234. And then 16 down, 218.
Yep.
Is that right? Okay, carried my 1. So the question I have is, when my buddy let me know his baby was going to be born early, I panicked, first of all, because I don't think about math in this situation. I think about, is your baby going to have fully formed lungs? Then, once I got the text that said, he screamed loudly, hurt all our ears, and he's beautiful, they took a picture, he's absolutely gorgeous. Then I can take a deep breath, cry a little bit, and be like, okay, so how unusual was 6 weeks early? That's when I start thinking about crunching the numbers, like how weird is that? Realizing that my buddy and his wife are off the charts because they're both Olympic caliber swimmers. So it's kind of hard to talk about lung function when you're dealing with that kind of gene pool. Mm-hmm. It's like Ashton Eaton and his wife and the kids they're going to have. Good Lord. Good Lord. Kid's going to jump out of the womb. So what I want to know is I want to talk about how preemies are defined. Because my buddy kept saying my baby's a preemie. He's going to be a preemie. He's going to be a preemie. What does that mean? 37 weeks. That's what we've heard. Now, I've never heard 37 weeks before, and since we have the data in days, let me see if what I've tracked down online syncs up with that. I heard the 5th percentile is the preemie cutoff. This is what I've heard. Let's see if it syncs up with 37 weeks. I like this. This is good. This is good. So here's number 1. This is what I've Googled many, many times. A premature birth. Now, I'm putting it in quotes, because a premature birth has to be defined as something. Obviously, it's to the left of average. It's obviously one that hasn't cooked long enough, right? That's what makes it premature. But the thing is, how far down does it have to be called premature? Because if they're a preemie birth, then they have, I'm assuming, access to other parts of the hospital that a non-premature birth wouldn't have. I'm assuming, like the NICU and things like that. So the definition that I've seen is it's the 5th percentile or lower. So what I want to know is that 37 weeks? What is this? What number of days is this? That's what I want to know right now. If a preemie is defined as the 5th percentile, okay, that's great, but you don't want to tell an expectant parents, you're okay, you're outside the 5th percentile, or you're not okay because you're inside the 5th percentile. You want to tell them, just like Jamie said, 37 weeks. Let's see, I don't know what it is. Is this a forwards or a backwards problem? Now, forget that Jamie said 37 weeks. We're going to see if our answer compares to that. So not knowing that the number 37 is involved in this at all we have is 5th percentile. Is it forwards?
Backwards.
Many votes for backwards, yes?
Yeah.
Ask yourself why. Because I gave you a percentage. I told you it's the 5th percentile. What didn't I tell you? How many days? I'm actually asking you what number of days. So you have the percent, you're looking for the days. That's what makes it a backwards problem. Yes! So actually, we need to look at this curve. If you're drawing while you're computing, and like I said, I like doing that. I think it's a nice tie-in. We know it's going to be. This is where it does get a little bit tricky here. You might be tempted to think it's over on this side of -2, because we're used to this being 95%, which it is. But the trick is we need 95% to be all the way to the right. So we need 50% to be here and then 45% to be here. So, and you'll see this when you graph it, it actually ends up being somewhere about here. Because if you cut it off here, there's actually 2.5% to the left of -2. Because there's 2.5% to the right of +2 because we're the 95 center. Does that make sense?
Yeah.
It's once again that psychology 1, 2, 3 kind of getting in the way. And you have to offset those sometimes in situations like this. So it's going to be somewhere around here. Oh, this is 5%. This is 5%. So the first question is, well, we know it's backwards. We start with a percentage. Next is, we have to take that percentage, feed it through to normal, and get a what? We're going to get ourselves a z-score next. We know it's between -1 and -2, and you might not even know that it's between -1 and -2. You might go straight to the TI and say, let it show me where it is. Good for you! Just make sure you know where you're shading. That's the kicker. Yes, Mr. Overhead Projector. So let's do it. More probabilities. Yes, backwards, yes! We'll shade to the left, okay?
Yeah.
Yeah, we'll shade to the left just because we have 5% shaded. You could, of course, shade 95% to the right, but just FYI, percentiles usually shade left, because that's the definition of a percentile, is the things you beat. So if you cut off at 5%, you end up with about a -1.64. About a -1.64. There's your Z. So that's how many standard deviations down you have to go to be the 5% cutoff. Tim, what's up? What's up?
What?
I thought you said something. I'm sorry.
No, totally not.
Oh, okay. Sorry. Misheard, missaw. So we know we're at 1.64 standard deviations down from average, but you don't tell the parents that. You tell the parents it's this many days. So step 3 is take that z-score
Yes.
and convert it to an x.
Okay.
Use this beautiful thing right here.
Okay.
So we got to take that standard deviation, multiply it by 16 days, and then add that, which is now negative, so subtract that from 266, and that takes the days off of average. It takes the days off of average. I have a pen in my pocket.
Times it by 160.
Yes, let's come down here. To get the average cutoff, we're going to take the average, which is 266, and then dump off the -1.64 times 16. So there's average, but you need to be below average by this amount. So what's that? 16 plus 2/3 of 16 is about 10, 26. 240-ish, somewhere in there? What do you guys get?
Yes.
240? Is that round to that?
That's rounded, yeah.
240 days. There's the cut. Crap. Throwing markers. There's your cutoff for preemies. 240 days. How does that sync up with Jamie's 37 weeks? I don't know. Let's see. I'm going to take 240 and divide by 7.
Oh, that's 34 weeks.
Ooh, I get 34. Interesting.
Yes.
Interesting. Interesting. Which means we have a 3-week, 21-day Wiggle room, that's a lot.
That's a lot.
Even with a standard deviation of 16, that's a lot. Interesting. I wonder. So you're saying 37, which means you're pumped up. You're higher than the 5th percentile. Or the 37 is higher than the 5th percentile at the 34-week mark. Interesting.
I think they're just trying to cover their butts.
Could be, could be. Because you see, mine's less restrictive than Jamie's number of 37 weeks. Because anybody born up here is still going to be considered a preemie by the 37-week definition, yeah? So that's interesting.
But normal is 2 sides of 40, so like 42 is the absolute maximum. They usually won't let you go past 39 and a half.
Good.
Or
Hold that thought too.
41.5.
Good.
But, I mean, within a couple of weeks either way is considered perfectly normal.
But that's where the standard deviation kicks in of 16 days. But what's interesting is that Jamie's figure and our figure are off by 3 weeks.
That's a lot.
That's what kind of blows my, almost 3 weeks. That even with the standard deviation of 16, that seems like a lot to me. But it's okay. Part of this is art, not science anyway. Because the average of 266 assumes you know when day 0 is.
Right.
Which a lot of moms do, but a lot of moms don't. So much of that is guesswork. So much of that is guesswork. So you don't know exactly what day 0 was. Very interesting. Very interesting. Which brings us to our last problem with human gestation, which Madeline just mentioned. So when I first moved here, we didn't have Max right away. He was born in 2007. We moved here in 2004. But we were in a neighborhood that was being built at the time. We were one of the first houses that was built in the neighborhood. And then we watched houses pop up around. And a lot of families in my neighborhood were having kids. And I kept track, just because we talk to them as they get pregnant and they raise their kids. You'll meet one of them, you'll meet Adeline in your 4th project. She was the amniocentesis test result that you'll analyze in your last project. But as the babies were being born, I noticed that an inordinate number of the women were being induced. At least I thought it was an inordinate number were being induced. I think it was something like, of the 10 births that my neighborhood had over the course of 3 years or something like that, it was something like 6 or 7 of them that were induced, and I'm like, that can't be right. That doesn't seem right. That seems like the human body is broken in some way if you have to pull the turkey out of the oven instead of the turkey coming itself. And I'm not saying that some of those inductions weren't due to scheduling. Because I know some doctors will do that. Like, well, I'm going to be on vacation for 3 weeks, and you're due a week after that, so let's get this baby out now, assuming it's past a certain due date. So I started, like I tend to do, I Googled. I started Googling, and I said, okay, what's induction? And the number I kept coming up with was, if you exceed your due date by 14 days, 2 weeks, if you exceed due by 2 weeks, we pull the plug, and the baby gets induced, or the labor gets induced.
Yeah, they did ours, mine, at 3 days shy of that.
There you go.
Because at 42 weeks, the umbilical cord starts to separate.
There we go. And loses nutrients at that point. And oxygen.
Yeah, everything.
Right? Everything.
Yeah, the baby
I'm
is
curious.
at risk.
266 divided by 7 ends up being 38 weeks. That's 38 weeks. So by my average is 38 weeks, 266. So by my definition of induced, 14 days past that would be exactly 40 weeks. You're saying 42.
42 is when the umbilical cord will start to...
on average.
Yeah,
starts
on average. So
right.
they will definitely make you deliver
Yes.
at like 41 and a half weeks.
Absolutely. So this is the importance too. You're understanding the importance now too of the difference between a single data point and a massive data points. When it's you and your child, you ignore the statistics and you focus on the individual tests that are being done, as long as they're not invasive. But when you're talking about it in general to see how procedures should be implemented or modified, you look at the entire data set. I'm not saying that you walk into your doctor's and you know what, don't bother with that last ultrasound. On average, we're fine. No. As long as it's not invasive, you get the ultrasound done, you get everything checked out. But when you're talking about a procedure or kind of a methodology, that's when you look at the averages. Thank you. So let's figure this out. Let's figure this out. By my research, let's see how it sinks in as far as with my experience. By my research, we induce at 2 weeks past the average due date. That's my research. What I want to know is, what percentage of pregnancies get induced by that definition? What percentage of pregnancies get induced? Now this is going to be, I think, parallel, Madeline, to what you were saying, because you were calling 40 and 42. I'm calling it 38 and 40, assuming the same standard deviation, it's the same problem.
Right.
assuming that we have about a 2 weeks, about a 16-day standard deviation, your question of 40 to 42 with 16 between is my 38 to 40 with 16 in between. So it's going to be the same percentage.
Well, it probably, I mean, you can also change where you're saying the pregnancy starts, because you could say it's
of
like
course.
where you, like, you know, the
Of
first
course.
day that you missed
Absolutely.
your period, and really you were probably pregnant before that.
Exactly, by who knows, I mean, it could be 30 days, yeah? Technically speaking, right? So, I mean, that's the thing. I mean, there's all kinds of wiggle in here. But even if we ignore all that and say that we're starting from 0, if you call it 40 and I call it 38 and you call induced 42 and I call it 40, we're still talking about the same distance.
Period, yeah.
It's this curve shifted over 2 weeks, same areas. So we're okay in that respect. It becomes a Math 111 transform. Sorry, I was going to apologize to John, he's not here. Okay? Forwards or backwards?
Forward.
Definitely forwards, yes? Definitely forwards, because I've given you a number. I've said let the pregnancy go out 14 days, 2 weeks past. If it starts at 266 and we go out 14 days, that goes to 280, yeah?
Yeah.
Let's use a different color. Let's use green. So here, 280 is the cutoff. So by this definition, no pregnancy lasts longer than 280 days. Because if it gets to 280, we pull the plug. But that doesn't mean that a pregnancy doesn't want to last more than 280 days. Those will get induced though. So all these pregnancies that are going to last 298 and 290 and 286, they still exist. And in the womb, they think they're going to do that, whatever a baby's thinking. But all of these pregnancies are going to get pulled at 280 by this definition. Make sense? That's what we have to find, that area. And it's a forwards problem. You guys have it. So we have to identify the data, and I think we have. We identified the data as 280 days. There's our data. Identify the data, convert it. Crunch that into a z-score. Convert that bad boy to a z-score. So we've got to go back up to this scale now. So we take the number of days, which is 280. Good. You're surprised as I am, Danny? Yes. This kind of made my head kind of like spin around when I got this number. 280.
Okay, wait, where did the 280 come from?
Because it's 2 weeks past due.
Okay. So
On average, it's 266. If you add 14 to that, you get 280.
got it, okay.
Does that make sense?
Yes.
I was being a bastard by throwing the weeks and the days together. Sorry. Give you a little prod before you go for Thanksgiving break. So 280 minus 266, which is 14. That's not 14. Over the 16 standard deviation. So we got 14 sixteenths, or 7/8 is your z-score. Z-score is 7/8. That's what we have to figure out. Starting at 7/8 of the z-score, starting at 7/8 of the standard deviation above, how much area are we picking up? And the answer, when I was thinking about this in my head, I'm like, holy crap, that's way bigger than I thought it was going to be. But as soon as you get to this point, you realize we've shaded quite a bit of the curve. So we run it as a forwards problem. We're going to shade to the right. Yeah, we're shading to the right. You guys can see, this is why I like drawing them first, because you can see what you have to enter in your machine. So it's nice. Left bound is 7/8. That's that z-score. Here she comes.
Oh, wait, right down is what?
19%. Shade to the right, left bound was 7/8. The 7/8 was a z-score. So starting here and adding it up all the
Oh,
way.
I went the wrong way. Okay.
That's okay. Well, you got the help. You got 81%. That's okay. You can also do it this way. Just realize you have to subtract 1 to get that. But that's 1 in 5 pregnancies. Right? If you call that 20%, which why not? What the hell? This is all kind of hand waving a little bit anyway, as far as what the center of the spread is. That's 20%. That's 1 in 5. That's a lot of pregnancies. It makes me think the human body should be evolving different, like a zipper. Something. Here's my baby, and zip it back up. Seriously, 1 in 5? So then I have to start questioning. I'm like, why do we pull them at 2 weeks? All kinds of good reasons. Madeline gives us a couple of them. There's all kinds of things that can go wrong and leave a baby in too long. But this it just seems high to me. I mean, it just seems high. Yes, I agree with getting a baby out when there's a health concern, but is it 1 in 5 pregnancies are a health concern? I don't know the answer to that. I'm asking it as a question. I don't know what the answer is. But it made me feel a little better about the number of inductions I was seeing in my neighborhood. Because knowing that, I'm like, well, I mean, I was on the high end of that by seeing like 5 or 6 out of 10. But still, it's got a precedent at least according to that definition. Is that believable? Yeah. Shelby, go ahead.
Okay, could we do a binomial?
Of this?
like you were saying, in your neighborhood to see if that's normal?
We could compare, yes, this is, you're asking a 244 question, I love it by the way. So we know it's 20%, so here's your binomial probability. I saw 5 or 6, and I can't remember what it was, out of 10.
Okay.
So that is binomial, isn't it? I have a probability of 20%. I checked 10 pregnancies, of which 5 or 6 were induced. You can run those numbers through DistFill and see how unlikely it was. Absolutely, thank you. I love it. Yeah. Because now we've gone from the length of pregnancy to the number of induced pregnancies.
Right.
Different random variable.
Yeah.
But very nice, it's gone from continuous to discrete. Love it. Thank you, sister. Smallest x 0, that would be no inductions whatsoever. Or they go to all induced at 10.
Okay.
All induced. We're obviously going to see more probability at the low end than the high end because it's only 20%. With an average of 2 out of 10, which would be 20%. Binomial, 0.2. I'm going to erase this board because we're done with it now. We don't really need it anymore for doing binomial. Yeah, very nice, Shelby. Switching the random variable around. Very good, very good. She's done. Here's what it looks like. Here's what it looks like. It's skewed, as it should be. 20% is further left than 50%. So here's the chance that none of them are induced, 1 are induced, 2. You should expect that to be the highest, because 20% of 10 is 2. So that should be the average in the mode. There's 3, there's 4, there's 5. That's what I saw, ish. I just saw 5 or 6, I do not remember which. But let me just trace it real quick and hop over there.
0.02.
2%, almost 3%. Which is, again, unusual. It's unusual. I shouldn't have seen that. But then again, it's hardly a random sample, like my neighborhood. I mean, maybe my neighborhood attracts people that want to get babies out quickly. I don't know. Throwing that out there. I have no idea that's even true. Sorry, neighbors, if you're watching.
Well, and they're all going to the same hospital, so
Yes.
like, that can.
So any bias that's in the hospital is in the entire neighborhood. Yeah, because this I'm assuming is a nationwide, if you will. These are nationwide things that I'm googling, not just Bend centric. So interesting stuff, huh? It's cool. So Renee, please.
So this is why, yeah, like figuring this out, is why the outliers should be, you're interested in the outliers?
Because it catches me off guard. If I'm expecting something and I get something that's convert, you guys are doing a great job of describing 244, just so you know. If you're expecting something and you get something completely counter to that, then you go back and analyze it numerically and say, okay, was that just my gut steering me the wrong way, or is this numerically different? This would be numerically different. It's far enough away from 20% to be like, something's different in your neighborhood. But yeah, this is how 244 is, this is how you find out that drugs work. This is how you find out if a speeding campaign is working on reducing speeding levels. I mean, this is how all those things work. Pretty rad. Pretty rad. Yeah, this, I mean, how many of you guys take 244? A few of you are? Not half of you, not half of you, yeah. What's that?
I said
At some point in life, exactly. You're describing how to use the 243 tools, and next week all we're going to do is one more tool. It's called the central limit theorem. That's going to be the bridge, the perfect bridge between the two. And it's just, yeah, you're describing it. If you're expecting something and get something else, it's called a contradiction. That's what we end up doing. Yeah, good. You guys brains full?
Yes.
We can skip Spitz and Phelps. We don't have to do Spitz and Phelps. That was just an extra I was going to throw on the top. So,
Thank you so much.
all right. Have an awesome Thanksgiving. Have an awesome Thanksgiving. Bring questions on the standard normal distribution for Monday. Let's get those answered. Then we're going to roll funny dice, and then we are going to talk about this thing called the wonderful thing called the central limit theorem, which is just more bell curve stuff. Honestly, it's all it is. It's more bell curve stuff. It's more bell curve stuff. Yeah, it'll be interesting. We'll bring back the 1, 2, 3 standard deviation stuff again.
What do you teach? What do you teach?
Same thing. 243, 244, or 105. One of each.
243. Back to 243? Because if 244 is next for winter,
What do I teach them all the time.
I have to take 244. I'm going to take lower class, but I can't take it next year.
Oh, scheduling. I understand. I don't know when it's going to be in the spring yet. I see what you're saying. So it's not what, it's when.
That's
Yeah,
right.
and I don't know the answer to that yet. I don't know the answer.
As long as it's when, I don't care.
Yeah, I get the early classes because I don't really just like them that much. But I just don't know. They just got to get it all squared away.
It's all good. I was like, oh, that's great.
I looked at the spring too, the early classes.
Oh, it is 8:15.
Yeah, early.
Big piece of coffee. They know working.
That's really
We'll stay tuned, because we're making up a hybrid section. We're creating a hybrid section. That's why this YouTube thing pissed me off so bad.
Yeah, and I do use your video.